This is another in the Vidiglobe Aviation Series. Today, you will be introduced to pilot navigation. In this tape, you will be shown how to prepare for and conduct safe cross-country flights. Topics covered will include planning your flight, navigation techniques, keeping a flight log, procedures to divert to an alternate airport, the basic use of radio aids for navigation, low-level flight, and flying in reduced visibility, and the actions to be taken if you get lost. There will be a series of review questions at the end of each section. The preparation includes taking into account present and anticipated weather, terrain, distance, and your competence as a pilot. In your planning, you will have to determine and maintain a heading and altitude. This means you will have to take into account drift and be able to estimate new headings to regain and maintain the desired track. You will also have the task of accurately calculating ground speeds to come up with revised estimate times of arrival, or ETAs. To do much of this, you will have to read charts and identify landmarks on the ground, as well as identify predetermined and new checkpoints. You will also be taught to recognize when it is necessary to divert from a planned route and fly to an alternate destination. The first item of business is to check the weather. Remember, pilot navigation flights can only be conducted if VFR weather prevails and is forecast to prevail over your route. You may get weather briefings either in person or by phone from an aviation weather specialist. If this is not possible, Transport Canada flight service stations can supply you with aviation area, terminal, and upper wind forecasts, along with hourly weather reports. Make sure to check the forecast reports against those of the airports you plan to land at. Pay attention to surface winds at your destination, as a strong wind or crosswind may preclude a safe landing. As weather conditions constantly change, plan to have an alternate destination where you can safely land. You should list all suitable alternates in chronological order on the flight log and circle them on the navigation chart. Enter the weather data on the flight planning form. Check NOTAM and field condition reports. Now, it is time to plan the route. The chart generally used for pilot navigation is the transverse Mercator projection, with a scale of 1 to 500,000. On this scale, 1 inch equals about 8 statute miles. Be sure you are using an up-to-date chart that is in good condition so that details can be seen. You may want to supplement aeronautical charts with road maps, since these generally include more bridge and road detail. But these should be used only as a secondary source of information, as distance scales and land features are not always as accurate. When determining your route, you will find the direct route is not always the most advisable. You will want to avoid routes largely over water beyond gliding distance from land. You will also want to avoid prohibited or danger areas and routes that include poor terrain. As you examine the map, look for possible checkpoints along the way. These are prominent features you can use as landmarks to establish your position, as well as help with the calculation of ground speed and revised ETAs. Major highways, rivers, railways, and lakes are examples of such landmarks. Your route should include as many of these features as possible. It is not a good idea to plot the track from airport to airport, especially if it is a busy or unfamiliar one. It is better to set the heading for near your final destination and then navigate the short distance to the airport. It is preferable to make the set heading point a nearby, easily identifiable landmark, such as a rail or road intersection, bend in the river, tower, or a small village or lake. This allows the pilot to visually fly from the airport to the heading where he can climb to cruising altitude. Climbing to height over a departure airport is dangerous and a waste of time. However, if you cannot find a suitable landmark, there is no alternative but to set the heading over the airport. Use a yellow tip pen to draw your track line from the set heading to your destination point. Now, check the map again to note the elevation of the terrain and any hills, peaks, or other obstructions. Make sure you will not be flying through any danger or prohibited areas. Make a list of alternate airports and keep track of where your checkpoints are. To help you make in-flight corrections to any deviation from your track, draw drift lines on either side of the track line. These should be drawn at 10 degrees on either side of the track line from both the set heading and the destination points. Later in the tape, you will be shown how these drift lines can help you get back on track. To help you make quick distance calculations, the track line should be marked at 10 nautical mile intervals. Or you may want to divide the track line at the quarter, half, and three-quarter marks. Before continuing with the technique of pilot navigation, a word about the paperwork and how to fill it in. Use the flight planning form to keep track of all information about your trip. Information should include the cruising altitude, true airspeed, track and wind velocity. Other pertinent information, particularly weather and landing runway details, should be added for current and future use. When determining the track, it is best to place the protractor at the midpoint of the track line to measure its angle with the meridian of longitude. This offsets any error that occurs on the transverse Mercator projection. Airspeed corrections are made using your navigation computer. True airspeed is used for all navigation calculations since indicated airspeed will vary with temperature, pressure, and altitude. The conversion can be done quickly on your circular navigation computer. Because wind velocities vary with altitude, they must be taken into account when preparing the flight plan. It is one of the factors which will determine your cruising altitude. The other form you will fill out is the navigation log. This will give you an organized record and schedule. It also reduces the possibility of forgetting important data and having to compute problems in flight. Once you know the wind velocity for the altitudes you will fly at, you can calculate headings, ground speeds, and times. Enter these on the navigation log. Itemize all tracks, headings, distances, speeds, and other information pertinent to your trip. Fuel requirements should be figured out, and these should be checked against actual consumption en route. And remember, it is mandatory to file a flight plan, flight notification, or flight itinerary prior to any flight beyond 25 miles of the airport of departure. This lets the authorities know where you might be should your aircraft be overdue. It is imperative you close your flight plan by notifying the appropriate agency when you reach your intended or alternate destination. Before getting into the section on navigation using a chart, some notes about the instruments on your aircraft. The magnetic compass will not give you a true reading when the aircraft is being turned, banked, accelerated, or decelerated. To get an accurate reading, you must be in straight and level flight at a constant airspeed. A good rule of thumb is that an aircraft turns at about 3 degrees per second in a standard rate turn. Therefore, to make a 90-degree turn, the aircraft would have to be held in a standard rate turn for 30 seconds. Although speed and altitude changes may cause errors in the heading indicator readings, they are so slight that they can be ignored for all practical purposes. However, it should be set manually by the pilot every 15 minutes because it is prone to precession errors. The altimeter also has to be reset from time to time in different locations because of changes in atmospheric pressure. You can obtain current altimeter readings from control towers and flight service stations, or by tuning into automatic terminal information service broadcasts. Now, take time for this review of the material covered so far. Why must alternate destinations be considered when preparing for a cross-country flight? Why must alternate destinations be considered when preparing for a cross-country flight? Weather or other factors may force you to divert to another airport. List all of these alternates in chronological order on the flight log form. Flight regulations require that prior to any cross-country flight, you become familiar with all available information appropriate to the intended flight. How would you meet this requirement? Flight regulations require that prior to any cross-country flight, you become familiar with all available information appropriate to the intended flight. How would you meet this requirement? By completing a flight planning form and the navigation log. This will list the pertinent weather information, as well as tracks, headings, distances, speeds, times, and fuel requirements. Also, check NOTAMs and field conditions. When preparing your track, why would you not necessarily take the direct route? When preparing your track, why would you not necessarily take the most direct route? Factors such as poor terrain, prohibited or dangerous areas, and other obstructions may preclude a direct route. You also want to avoid flying over water beyond gliding distance from land. Now, we will show you how to develop your skill in map reading. If visibility is normal, a well-trained pilot should be able to fly directly to the destination by map reading alone. When practicing map reading and cross-country navigation, you should be flying at least 2,000 to 3,000 feet above the ground. Remember, it is harder to pick out landmarks and find them on the map at lower altitudes because you can't see as much of the terrain. When navigating with a map, a good rule of thumb is from watch to chart to ground. That is, note the time, study the chart, and anticipate what you should be seeing on the ground. Here's a tip you will find useful. When flying by map reading, orient the map in the direction the aircraft is proceeding, even though it may mean the lettering on the map is sideways or upside down. It is important that you develop the ability to estimate, something that is achieved through constant practice. While in flight, estimate the bearing and distance the aircraft is from an airport, town, or checkpoint. Observe the natural signs of surface winds and their direction. Get into the habit of estimating the size of objects on the ground and the distance they are from each other. If you fly over a field, estimate its length and width and determine if it would be suitable for an emergency landing. In other words, be as familiar as possible with your route. Once you are in flight, you will find that inaccuracies in forecast winds and flying the aircraft will throw you off track. Before you are shown how to make corrections, let's become familiar with the following terms. Required track is the proposed path of the aircraft over the ground. The track made good is the actual path you will fly. Track error is the angle between the track made good and the required track. Note that this is always expressed as being the number of degrees to the left or right of the required track. The opening angle is the angle between the required track and the track made good. The closing angle is found between the old required track and the new required track to arrive at your destination. Earlier, we marked the map for our flight with the 10-degree drift lines. You will now be shown 3 ways to use these lines to correct your heading should you drift off course. The first method is the double track error method. You have calculated your heading to reach your destination at 150 degrees. About 15 miles from point A, you accurately pinpoint your position at B. Using the 10-degree drift lines as a guide, you estimate the opening angle, or track error, is about 6 degrees to the left of the required track. Now, if you alter your heading by 6 degrees, you will fly a path parallel to the required track. What you must do is double the track error to get back on course. Your new heading will be 162 degrees. At point C, you will regain your required track. It should take you approximately the same length of time to reach C as it did to fly from A to B. If possible, confirm your position with landmarks on the ground. Upon reaching C, alter your heading by subtracting half of the correction that was applied to the original heading. This means your heading will be 156 degrees to maintain the required track. Another way to regain your required track is the opening and closing angles method. This method is useful if more than half of your flight is completed before you are able to determine your position. But it can be used at any distance along the track. This happens when there have been no features on the ground on which you can fix your position. In our example, you have flown more than half the route before pinpointing your position at point C. Using the 10-degree drift lines, you find the opening line about 4 degrees to the right of the track. The closing angle to the destination appears to be about 8 degrees. In order to fly directly to your destination, add the opening and closing angles and adjust your heading by this amount to the left. Again, if your heading was 150 degrees, subtract 12 degrees, which gives you a new heading of 138 degrees. The third method of getting back on track is the visual alteration method. Use this method if you can positively identify a landmark on the required track. In the example, your heading is 150 degrees. At point B, you notice a track error of about 6 degrees. You then fly to the positively identified landmark at C. To maintain the required track, you now alter your heading to 156 degrees. Before proceeding to the final section of this tape, take time to complete this review. The use of 10-degree drift lines permits you to regain track in a prescribed manner should you go off course. Why is accurate heading control necessary for this method? The use of 10-degree drift lines permits you to regain track in a prescribed manner should you go off course. Why is accurate heading control necessary for this method? To ensure mathematical accuracy. Using the double track method, a reasonable distance should be covered before the drift error is determined and corrected. Why? Using the double track method, a reasonable distance should be covered before the drift error is determined and corrected. Why? Errors detected early in the flight are magnified considerably. The final section of this tape deals with in-flight navigation procedures. As soon as possible after takeoff, get the aircraft on the desired compass heading for the first leg. This should be done either over the airport or over a convenient checkpoint. Enter the time over the set heading point and calculate the ETA. To ensure accuracy, it is important to begin the navigation exercise directly over the planned set heading point. Revisions to the ETA should not be attempted until you are between 10 and 25 miles from the departure point. Rely on navigation instruments in the aircraft rather than inexperienced personal judgment. Maintain a steady planned heading and airspeed. If you do not recognize where you are, do not suspect the compass of inaccuracy. Continue to hold a steady heading until you reach a recognizable checkpoint. You will have little time for log keeping in the air, but there are some items that must be recorded. These include compass headings, the time the compass heading is altered, the ETA at the destination and planned turning points, time over checkpoints and turning points, and new ground speeds and revised ETAs. As you are flying, keep an eye out for checkpoints and note the time to check your progress. Watch the clock as well. Time is a key element of navigation. It helps you locate checkpoints by preventing you from looking for them too soon or too late. Do not fly a zigzag from checkpoint to checkpoint. There is nothing wrong with not arriving directly over a specific point. Any changes in heading should be deliberate with the goal of flying in as straight a line as possible. One skill you should develop is the ability to quickly estimate a heading to an alternate destination should the flight become impractical. The calculations are the same as you would use in pre-flight planning, but because of having to simultaneously operate the aircraft, you must take advantage of all shortcuts. With a little practice, you can quickly determine headings with reasonable accuracy. Interpolate and mentally transpose airways and air routes on the chart, or the azimuth information on the compass rose that encircles VOR stations. Alternates can be determined quickly by studying the chart or from the azimuth information on the compass rose encircling the VOR. Use a pencil or the edge of your hand as a straight edge. If airways or a compass rose is not close enough on the chart, estimate angles by taking them as a fraction of the 90-degree angle between the meridians of longitude and the lines of latitude. If possible, draw a freehand line on the chart from the divert point to your alternate destination. Estimate distances using your thumb and index finger as a set of dividers. Here's another tip. On Canadian charts with a scale of 1 to 500,000, the compass rose around VOR stations is about 30 nautical miles. Always divert to the airport which has the easiest route to follow, be it a highway, power line, river, or other landmarks. Remember, you are generally diverting in an emergency or near emergency situation, so this is no time to test your pure navigation skills. To compensate for wind, use forward landmarks as a means of staying close to the desired track. In the case of poor visibility, you will have to rely on low-level navigation. At these altitudes, you will find your field of view extremely limited, especially in rough and hilly terrain. As well, because you will need to give greater attention to handling the aircraft, you will have less time to look for landmarks and checkpoints as you pass over them. Try to pick easily identifiable features such as railway lines or roads that run perpendicular to the track. Flying at low levels also means you have to keep an eye out for hazards, such as broadcast towers, power lines, factory chimneys, and other objects. Your set heading procedure should be carried out before you descend to the lower altitude and limit your navigation to map reading. If altitude is critical, frequently look outside while making log entries to make sure you don't fly into the ground. If you are uncertain of where you are, climb as high as necessary to give yourself a better view of the ground and try to find a landmark. Here are some points to follow should you become lost while flying cross-country. First, remain calm and hold a steady heading. Check the heading indicator against the compass. Check all previous calculations by studying your chart and your log. Check for a possible wind shift. Draw a circle of uncertainty. You do this by drawing a circle on the chart around the position you would be in if you were on track and on time. The radius should be at least 10% of the estimated distance flown since the last confirmed position. Now, examine the circle for prominent features you might recognize on the ground. When you recognize a landmark, fix your position. You might also try to get a bearing using radio aids. Usually, you will be able to establish your position in a short time. DF steers are available from air traffic control in many areas, and if you are in radio range, a heading will be offered. If you decide you are definitely lost, notify air traffic control by radio or try to contact any other control agency. Once establishing radio contact, transmit your general position and the amount of fuel you have left. Ask for any assistance you need and indicate what action you plan to take. In an extreme emergency, you should broadcast a Mayday distress message on 121.5 megahertz, giving the aircraft type, the nature of the emergency, the amount of fuel left, assistance required, and your immediate intentions. Listen on the same frequency for instructions. If you have no idea which direction to fly, set up a triangular pattern at endurance power settings at the highest practical altitude. This will alert the radar network. If fuel shortage is a problem, save enough to complete off-airport procedures. Now, take time for this final review. Ground speed checks are essential during cross-country flight. What problems are associated with obtaining a ground speed check within a few minutes after setting heading? Ground speed checks are essential during cross-country flight. What problems are associated with obtaining a ground speed check within a few minutes after setting heading? Any errors over a short distance are magnified considerably. It is best to wait until you have flown 10 to 25 nautical miles before making this check. What information must be logged while in flight? What information must be logged while in flight? The pilot must record each compass heading, the time the aircraft sets out on each heading, the ETA at the destination and turning points, time over or by checkpoints, and turning points, and new ground speeds and revised ETAs. If you determine you are lost, what action should you take? If you determine that you are lost, what action should you take? Keep your heading steady and check the heading indicator against the compass. Check all of your previous calculations by studying your chart and log. Check for possible wind shift. Draw a circle of uncertainty. Try to get a bearing using radio aids. If you still cannot determine your position, contact air traffic control or any other control agency. Once you have reached someone, transmit your general position, the amount of fuel remaining, ask for whatever assistance you need, and indicate the action you plan to take. That completes the tape on pilot navigation. Look for other tapes in the Vidiglobe Flight Series.